This presentation gives introduction of alternating current circuits with the following objectives. Look into the introduction of AC circuits, define AC voltage source, resistors in AC circuit, phasor diagram, RMS current, voltage and power. Electrical appliances in the house use alternating current circuits. If an AC source applies an alternating voltage to a series circuit containing resistor, inductor and capacitor, what are the amplitude and time characteristics of the alternating current? This is the main background, or this is the main thing that should be considered in analyzing the AC circuits. An AC circuit consists of combination of circuit elements and power source. The power source provides an alternating voltage V. Notation are lowercase symbols will indicate instantaneous values, capital letters will indicate the fixed values. The output of AC power source is sinusoidal and varies with time according to the following equation. V is Vmax into sin omega t, where delta V is instantaneous voltage and Vmax is maximum output voltage across the source. It is also called as voltage magnitude voltage amplitude. Omega is angular frequency of the AC voltage. The AC voltage is represented or alternating quantity is represented sinusoidally or with a cosine waveform, where this T is the time period and F is the frequency of the source. Angular frequency is omega is 2 pi F or 2 pi by T. The voltage is positive during one half cycle and during the second half cycle the voltage is negative. Current in any circuit driven by an AC source is alternating current that varies sinusoidally with time. Commercial electrical power plants in the USA use frequency of 50 Hz corresponds to an angular frequency of 377 radian per second. In Indian system and in UK system, frequency is 50 Hz and correspondingly angular frequency is 314 radian per second. Resistors in AC circuit. When a resistor is connected across the AC circuit, then how we go with the analysis. Consider a circuit consisting of AC source and a resistor. The AC source is symbolized by a small circle and then a tilde inside the small circle. This indicates the source is an alternating source. VR is Vmax, that is, this voltage across the resistor is nothing but voltage across the source, which is Vmax into sin omega t. VR is instantaneous voltage across the resistor. Resistors in instantaneous current in the resistor is IR is Vmax sin omega t by R. This Vmax by R is written as Imax. So Imax into R is your Vmax now. The graph shows the current through and the voltage across the resistor. Current and voltage in the resistor get their maximum values at the same time. The current and voltage are said to be in phase. When current and voltage achieve the maximum and minimum values in the alternating quantity at the same time, then we say that they both are in phase. For sinusoidal applied voltage, the current in a resistor is always in phase with the voltage across the resistor. The direction of the current has no effect on the behavior of the resistor. Resistors behave essentially the same way in both DC and AC circuits. To simplify the analysis of the AC circuit, a graphical constructor called phasor diagram can be used. A phasor is a vector whose length is proportional to the maximum value of the variable it represents. The vector rotates counterclockwise at an angular speed equal to the angular frequency associated with the variable. The projection of the phasor onto the vertical axis represents instantaneous value of the quantity it represents. An alternating voltage can be presented in a different representations. One graphical representation is using rectangular coordinates, voltage on vertical axis and time on the horizontal axis. The phasor space in which phasor is drawn is similar to polar coordinate graph paper. The radial coordinate represents the amplitude of the voltage, the angular coordinate is the phase angle, and the vertical axis coordinate of the tip of the phasor represents the instantaneous value of the voltage. The horizontal coordinate does not represent anything. Alternating current can also be represented by phasors. The average current in one cycle is zero. Resistors experience a temperature increase in which depends on the magnitude of the current but not the direction of the current. The power is related to the square of the current. The RMS current is average of importance in an AC circuit. RMS stands for root mean square value. IRMS is I maximum by root 2, which is 0.707 times the maximum value. Alternating voltages can also be discussed in terms of the RMS values, where VRMS is V maximum by root 2, 0.707 times V maximum. Power. The rate at which electrical energy is delivered to a resistor in the circuit is given by P is I square R. I is instantaneous current. R is the resistance. The heating effect produced by an AC current with maximum value of I max is not same as the DC current of the same value. Maximum current occurs for small amount of time. Average power delivered to a resistor that carries an alternating current is P average is I RMS square by R. RMS values are used when discussing alternating currents and voltages because AC ammeters and voltmeters are designed to read the RMS values. Many of the equations that will be used to have the same form as their counterparts. Power in AC circuit. The average power delivered by the AC source is converted into internal energy in the resistor. P average is 1 by 2 into I max into V max cos phi or IRMS VRMS cos phi. Cos phi is called power factor of the circuit. We can also find average power in terms of R. P average is I RMS square into R. When the load is purely resistive, phi is 0 and cos phi is 1. So P average is I RMS into V RMS. Average power delivered by the source is converted into internal energy in the resistor. No power loss are associated with pure capacitors and pure inductors in AC circuit. In capacitor, during one half cycle energy is stored and during the other half cycle energy is returned to the circuit and no power loss occur in the capacitor. In inductor, the source does work against the back EMF of the inductor and energy is stored in the inductor. But when current begins to decrease in the circuit, the energy is returned to the circuit. The power delivered by AC circuit depends on the phase. Some applications include using capacitors to shift the phase to heavy motors or other inductive loads so that excessively high voltages are not needed. In this presentation, we have seen introduction of AC circuits, we have defined AC voltage source, the analysis with resistors in AC circuit, phasor diagram, RMS current, voltage and power. Try answering these following questions. Thank you.